In this section, we're going to start learning about progressive web apps. What exactly is that? It's a set of features that bring existing mobile features onto the web. It might sound strange at first, but there are many reasons why we would want to do this. There are features available in mobile apps that increase user retention. This reason is the biggest reason why progressive web apps became a thing. Let's think about this for a moment. What are features we would typically find in a mobile app, but not in a web app? Mobile apps can be opened from the home page, offer offline support, synchronize in the background, push notifications, have access to hardware, and geolocation. The goal of any app is to maintain and increase user retention. It would be incredibly useful if we could bring the mobile experience to our web apps. Normally, we would need to learn Java to write Android apps or Swift for Apple. This would mean having to maintain at least 3 different code bases for providing the same experience. It's not just challenging, but costly too. This is where progressive web apps come into play. We can continue to write our applications in HTML, CSS, and JavaScript. There are APIs available in browsers we can leverage to bring a mobile experience to our mobile users. 3 characteristics make an application a progressive web app. Firstly, it must be capable of utilizing the features on any given device. In the past few years, browsers have been pushing new features we can use to enhance our apps. We can access the camera, retrieve the user's location, and other things that weren't available previously. Secondly, it must be reliable. Performance makes a significant impact on user experience. Users expect apps to be responsive on every touch. Browsers introduce Cache API we can use to implement different caching strategies. We'll be able to deliver files to the user from the cache or the network. If a user is offline, the app can still be partially functioning. We live in an age where the internet is blazingly fast, but there are still a few problems with connectivity. For example, if a user goes under a tunnel, they may lose connection temporarily. They may perform actions in our app that requires an internet connection. Progressive web apps are capable of synchronizing the state of an application with the server after connectivity is restored. Thirdly, the app must be installable. One of the main issues with web apps on mobile is having to open the browser and navigate to the app. Native apps can be directly opened on the home screen. This feature makes them a better experience for users on mobile devices. We can take advantage of a progressive web app feature to make our app installable. Users will be able to click on an icon that'll directly take them to our web app. It removes a step in the process, but a significant one nonetheless. If we can implement all 3 of these characteristics, we have a progressive web app on our hands. We'll jump into the code in the next set of lectures. There's one last thing I want to address. What's the difference between single-page apps and progressive web apps? A single-page app is an application that will dynamically rewrite the current web page with new data. The user doesn't have to fetch an entirely new page. It's intelligent enough to swap out the pieces that need to be swapped. The application we've been working on is a single-page app. A progressive web app is used to describe a set of features for allowing the developer to add mobile features to a web app. They're purely additive features. You don't have to add these features to a single-page app. You can add them to a traditional site. If you've ever been prompted by a site to give you notifications or know your location, you've encountered a progressive web app feature. We're not forced to write a single-page app to leverage progressive web app features. The idea of a progressive web app is not a replacement for single-page apps. It's meant to be additive for traditional sites and single-page apps. Hopefully, I've clarified what a progressive web app is. Let's dive into the code in the next set of lectures. In this lecture, we're going to learn about the manifest file. Creating a manifest file is typically the second step most developers take for creating a progressive web app. To understand why, check out the link in the resource section of this lecture. We can make our apps installable. This will mean the user can add the app to their home screen. If they click on the app, they'll be taken directly to the application they installed. They won't have to open the browser and input the URL to our app. This is highly beneficial because it gives us more presence in the user's browsing experience. This page goes over how we can make an app installable. If we scroll down, we'll come across a checklist of things we need to do to make our app installable. Let's run through the checklist together. The first item says the web app must not have been installed already. This makes sense. We don't want to ask the user to install our app if they've already installed it. The second item states the user be engaged with our app. Most browsers will not ask if the user would like to install the app right away. Every browser expects some user engagement before asking. The criteria as to when a browser asks if the user would like to install the app varies from browser to browser. In most cases, it happens when the user has visited the app 2 times for at least 5 minutes. The first 2 items are beyond our control. The browser handles both items. The third item says we need to serve our app over HTTPS. This is for security reasons. Progressive web apps will have more access to the user's device. It's always good to make sure information is transmitted over a secure connection. There is one exception to this rule. Apps can be installable over localhost. This is for developers to be able to test the installation process. The next item states we need to have a manifest file. A manifest file is a JSON file that describes our application. We can assign a name, add icons, and set the orientation of our app. There are various settings we can configure in the manifest file. It's necessary to add this file because phones will use the name and icon we list in the file to display our app on the home screen. The documentation tells us what properties we need to add. We'll get to this in a moment. The last item in the list tells us to register a service worker. A service worker is a file that can run in the background to handle tasks outside of our app. We'll be looking into what a service worker is in another lecture. We're finished reviewing what needs to be done. We can ignore the first 3 items because they're out of our control for the time being. We'll be focusing on the last 2. We have the option of creating both files, but there's an official solution we can use. The Vite community has curated a plugin for enabling PWA features in an app. Let's install it. Switch over to the command line. If you have the server running, turn it off. Next, run the following command: npm I vite plugin PWA -d. After installing this package, it must be configured with Vite. Open the vite.config.js file. At the top of the file, import the Vite PWA function from the Vite plugin PWA package. Next, inside the plugins array, call this function. This function will handle most of the work. It'll generate the manifest file. In addition, it'll create a service worker, which we'll talk about in a future lecture. Let's configure the features by passing in an object. In this object, set the register type property to auto update. Progressive web apps are partially functional offline. To achieve this feature, the browser must download files from the server and cache them. Caching is a feature for storing a local copy of a file in the browser. This behavior can boost the performance of a site. A file does not need to be downloaded twice. However, it can cause issues. What if a file is updated? The user should download the latest copy. By setting the register type property to auto update, the app will automatically update itself with the latest copy. After adding this property, add the dev options object. This object can contain configuration settings for the development server. Let's set the enabled option to true. By default, a manifest file does not get produced for development servers. It'll only be created during production. We can override this behavior by setting this option to true. That's it. Let's try turning on the server. In the command line, run the npm run dev command. The server has successfully started. The question is, where is the manifest file? I'll answer this question in the next lecture. In this lecture, we're going to build the manifest file. The plugin will not generate a manifest file until the project has been built. This is a gotcha that can make developing progressive web apps tricky. Manifest files are cached, which can make development difficult. We can get around this behavior by enabling dev mode from the Vite configuration file. Luckily, we took care of this step in the previous lecture. Let's try viewing our app in the browser. Initially, nothing seems different. However, we can use the developer tools to view the manifest file. Under the Application panel, this panel has a section dedicated to progressive web app features. On the sidebar, click on Manifest. If our app did not have a manifest file, this page would be blank. As you can see, a manifest file has been detected from our app. Vite is generating this file in real time. It's not available from our project. The manifest file will have the minimum configuration for registering an app. According to the page, a few errors are being produced. We're going to try our best to eliminate these errors. Unfortunately, not all of them will go away. A progressive web app must be served from a real server, not a development server. There are some errors that won't go away until the app is pushed to production. Let's try viewing the manifest file. At the top of the page, there's a link for viewing this file. Click on it. The developer tools will switch to the Sources panel for viewing this file. At the end of the day, a manifest file is a JSON file, plain and simple. It's great that Vite creates this file while the server is running, but what about for production? We'll need the manifest file for a live server. We can produce the manifest file by running the build command. Switch over to the editor. In the command line, turn the server off. Next, run the following command: npm run build. The build command will optimize our application for production. Unlike the dev command, this command will not watch our files for changes. It builds the project once. That's perfectly fine. We're not interested in watching our files. A new directory in our project will appear called distribution. The files in the directory are the files we'll upload when we deploy the project. Let's look inside. The main focus is to learn about the manifest file. We'll find the manifest.json file. Here's what it looks like. It may be unformatted. I'm going to quickly format this file for readability. Let's go through the properties one by one. The first property is the name. This property is the name of the application, which will be displayed to the user when interacting with your application. The plugin will grab this property from the package file. The second property is the short name property. Some devices have limitations for displaying names. The short name property will be used when room is limited. It's recommended to set this to something short and concise. If we don't provide a value, the name from the package file will be used. Let's move on to the next property. The start URL property is the URL to where the user will be taken when they click on our app on their home screen. We want to redirect them to the root directory of our app. Afterward, we have the display property. We can create the illusion that our app is independent from the browser. If a user opens an app from the home screen, we can remove the address bar from the browser. Our app will still be opened in a browser, but the user won't be able to navigate away to another site. We can set the display property to standalone to hide the browser's toolbar. This value will leave the impression the user has installed an app and not just a shortcut. Up next, we have a property called background color. It's self-explanatory. We can configure what background color we want for our app. Following this property, we have an option called language. As you would suspect, we can configure the language of our app by setting this property to the locale code of our preferred language. In this example, the language will be English. The last property is called scope. The scope can restrict the user to a specific path in our app. If the user navigates outside the scope, the app will convert itself into a normal browser. For this example, let's point the scope to the root directory. Those are all the properties that were configured for us. In the following lecture, we will add more options to the file. For now, let's leave it as is. How do we verify the browser is loading the manifest file? We need to tell the browser to load the manifest file. It will not search for it automatically. We can do that by adding a link tag in the head section of the document. Let me show you the index.html file that was generated with the production build. Inside it, we'll find a link tag to the manifest file. The rel attribute must be set to manifest to tell the browser what the file will be used for. Great, we've got a manifest file. We'll stop here for now. In the next lecture, we'll look at how we can configure the manifest file. In this lecture, we're going to learn how to configure the manifest file. The plugin we installed will provide us with default values. Every value is completely overridable. Most likely, you will want to change the values to better describe the application you're building. In the resource section of this lecture, I provide a link to the documentation page for the PWA plugin we installed. This page goes over how we can configure the manifest file that gets generated by the plugin. It's as simple as modifying the Vite configuration file. Let's continue extending the configuration to include additional settings. In your editor, open the vite.config.js file. Through this configuration file, we can configure the PWA settings. This includes the settings for the manifest file. Inside the Vite PWA object, add an object called manifest. There aren't many settings we'll want to configure. On this object, we're going to change the name, theme color, and icons. That's it. The name of the app can be configured by adding the name property. We'll set it to the following: Music App. We can assign a color to our application. It helps the browser understand the main color of our UI elements. The theme color of the app can be changed by adding the theme color property. We'll set it to the following: #FF5E3A. The last property is called icons. The icons property is an array of objects where each object represents an icon. Most platforms support various sizes. We're not going to review every site. At a minimum, browsers require at least one icon. For this course, I've provided an icon for registering our app as a progressive web app. In this array, add an object with a property called source. The value for this property must be a path to the file. Let's set it to the following: assets/image/pwa192x192.png. Next, we must add the dimensions for the size. Add sizes property with the following value: 192x192. Lastly, we must add the MIME type. Set the type property to image/png. These properties must be added to each icon. The PWA plugin will be able to correctly add these settings to the correct properties in the manifest file. We're finished with configuring the plugin. The next time we build the project, the manifest file will use the name and colors we added in the configuration file. I recommend checking out the documentation to learn more about the properties we can add. It'll tell you what default values it'll use when we don't provide one. It's time to check the manifest file with the developer tools. In the browser, refresh the page. Navigate to the application panel. Most of the errors have gone away. If we're able to clear these errors, our app is installable. That wraps it up for this lecture. We'll continue in the next one. In this lecture, we're going to learn about service workers. We glossed over them during the installation of the PWA plugin. I want to dive into what service workers are and why they're important. They play a huge role in how our app will behave offline. That might sound strange, but it's completely possible for an app to be usable offline. There are some limitations with offline support. Let's get into it. Let's address the first question you may have. What is a service worker? A service worker is a JavaScript file that runs in the background. It is mainly separate from the application code. Because of that, service workers can run parallel to an application. What exactly does that mean? It means our application code and service workers can't block each other. JavaScript is a language that runs on a single thread. If we write synchronous code, we'll experience blocking. This is resolved by using callbacks or promises, aka asynchronous code. Let's say we had a synchronous operation. This means anything else won't be able to run until the operation is complete. However, there is an exception to this problem: service workers. A service worker will not be blocked from running even if a synchronous operation is taking place in our application. It's because they run on a separate thread in the background. The main benefit is that neither script will block each other from performing tasks. Our application will continue to run smoothly while a service worker is running. We can perform a couple of tasks with service workers. We can cache files, push background notifications, and sync the application. Service workers are where we can write a majority of progressive features. There are some limitations with service workers you should be aware of. Firstly, they don't have access to the DOM. We can't add, remove, or update elements in the documents. Service workers aren't meant to update the document. That job should be left to the main application. Secondly, there's limited browser support for service workers. It's a relatively new feature. Adoption is slowly progressing, but you shouldn't completely rely on service workers if users are on an old device. With that being said, let's try creating a service worker. There are two approaches to creating a service worker. The first approach is to create the file manually. The second approach is to use Workbox. In the resource section of this lecture, I provide a link to this library. Workbox is a library developed by Google. It'll help us with creating a service worker. Believe it or not, creating service workers can be a tedious task. Rather than attempting to create a service worker, we're going to use Workbox. It makes the process a whole lot easier. Luckily, Workbox is configured with the PWA plugin. Our job is to register the service worker from our script. In your editor, open the main.js file. I recommend registering the service worker as early as possible. We don't have to use a lifecycle hook. We can register it immediately. At the top of the file, import a function called register.sw from the virtual::PWA register package. Next, call this function after the import statements. Lastly, pass in an object with a property called immediate. Its value will be true. The register.sw function will do most of the heavy lifting. It'll load and register the service worker. The immediate property will instruct the function to register it immediately. Otherwise, it'll wait until the window has loaded. For our case, we do not need to wait for the rest of the app to load. That's it. The service worker should appear in our script. Let's refresh the page in the browser. In the developer tools, switch to the application panel. The error from the previous lecture is gone. That's great. Let's try testing offline mode. Switch to the network panel. There's an option for going offline. Select this option. After doing so, refresh the page. The page does not get cached. What's going on? By default, the Vite PWA plugin will configure our app to work offline. So, why isn't it working? The reason is simple. Vite disables caching by default. Without caching, our app will not work offline. To get around this problem, we must build the project and preview the builds. Switch over to the command line. Let's turn off the server. Next, run the npm run build command. Afterward, run the npm run preview command. The preview command will create a server for previewing the final build of our project. Unlike the development server, it will not watch our files for changes. The URL for the preview server will be different from the development server. Let's check it out. If the browser is offline, enable online mode and refresh the page. Lastly, enable offline mode. Refresh the page. This time, the page works. Keep in mind, the app is not fully functional. Only the JS, CSS, and HTML files are working. Everything else, from images to audio files, is not working. Let's try improving the offline experience in the next set of lectures. In this lecture, we're going to talk about caching. I mentioned it in the previous lecture. Just to make sure we're all on the same page, I want to quickly review what caching is. Caching is a concept where copies of data and assets are stored for faster delivery. It sounds like a simple concept, but there's more complexity than you can imagine. There's a famous quote by Phil Carlton that goes like this: "There are only two hard things in computer science, caching and naming things." Caching is meant to increase the performance of an application, but the question is, when and how do we use caching? That's a tricky question to answer because there are various strategies available for implementing caching. Let's imagine we're trying to cache CSS files. Typically, assets like CSS files don't change frequently. We don't need to make a request over the network to retrieve the CSS file. We can request it once and then store it in a cache. Subsequent requests for the CSS file will be served from the cache. This is what's known as a cache first, then network strategy. The browser will search for files in the browser's cache. The browser has an API we can use to store files locally on the user's machine. If the browser can't find a file on the machine, it will request the files from the network. If the server responds with a file, the file will be cached for subsequent requests of the same file. This strategy works incredibly well for static files. It's another story for data from Firebase. It's entirely possible for cached data from Firestore, but that's something we should take lightly. We always want to deliver the latest data from our database. At the same time, our app is mostly data-driven. If a user goes offline, they'll be able to see the site, but not the data. It'll mostly appear empty. We'll need to cache the data for when the user goes offline. There's another strategy we can use called network first, then cache. We'll always request the data over the network. The data returned by the network will be stored locally. We'll have a local copy of the data stored in the user's browser. If the user goes offline, we'll be able to use the data from the cache to make it seem like the app is still functional. We can even sync changes when the user comes online. The cache is only used for when the user is offline. We have two different strategies we'll want to implement if we want to provide a complete offline experience. These are not the only strategies available. If you were to search online, you'll find dozens of examples for different strategies. Luckily, by using Workbox, we can avoid most of the complexities of caching. However, it isn't always reliable. As we saw, it couldn't cache images. In the next lecture, let's try extending Workbox to include images in the caching process. In this lecture, we're going to extend Workbox by including images. Currently, I'm viewing the application offline. It's partially functional. While not always possible, we should always offer the best offline experience. I think it would be a good idea to cache images, which are not cached by our service worker. As mentioned before, we're using Workbox. Workbox is a tool that can implement different caching strategies for you. We can tell it exactly what we want to cache, and it'll take care of the rest. It'll know when the user is offline, when to deliver cache files, and when to update the cache. It's incredibly useful. We're going to be using Workbox to help us with caching. It's important to keep in mind of one thing. Workbox will not cache API requests. This includes requests to Firebase. Workbox will solely focus on caching static assets. We'll learn how to cache Firebase requests in the next lecture. In your editor, open the vite.config.js file. Inside the configuration object, add an object called Workbox. This object can contain configuration settings for Workbox. You can refer to the Workbox documentation for a complete list of options. Inside this object, we're going to add an option called glob patterns. If you've never heard of glob, let me briefly talk about it. It's common for computer programs to search for files within a system. However, you may not have a complete list of files. Rather than providing a complete list of files, you can create a pattern. If a file matches a pattern, it'll be added to the results list. Glob is a package for searching for files with patterns. The glob patterns option is an array of patterns. Let's add the following pattern as a string. Asterisk, asterisk, slash, asterisk, dot JS, comma, CSS, comma, HTML, comma, PNG, comma, JPG, comma. The pattern we're using will cache JavaScript, CSS, HTML, and image files. Let's test if this is true. Switch over to the command line. If the server is running, turn it off. After doing so, run the npm run build command. Next, run the npm run preview command. In the browser, refresh the page while being online. The app is functioning perfectly fine. Let's try going offline by switching to the Network panel in the Developer Tools. In this panel, switch to offline mode. Lastly, refresh the page. After refreshing the page, we'll continue to see the app. Workbox will deliver the files via the cache. On the Network panel, we can view the list of requests made by our application. Most of the requests are working perfectly fine. Under the Size column, the Developer Tools will inform us of the source of the files. It'll tell us that our service worker handled some of the requests. Workbox intercepted the request. It searched for the file in the cache because we're offline. If the file is in the cache, it'll respond with the file. This is why we're able to view the application. We can even browse around as if nothing went wrong. If you're interested in what files are cached, you can view them under the Application panel. There's a page that will list the files that were cached by the service worker called Cache Storage. There's one important point I want to make. The cache won't work unless there was network connectivity on the first visit. If we were to attempt to view the application without any of the files cached, we'd be presented with a different page. We can test this by clearing the storage. On the menu, switch to the Storage page. We can clear the storage completely. This will include data saved in the cache. Let's clear it out. Next, we'll refresh the page. After doing so, we'll be told we're not connected to the internet. The browser will not be able to load files from the cache. It'll default to showing the dinosaur minigame. It's important to understand this. We must have visited the application previously while we were online to be able to cache the assets. I'm going to go back online quickly. So, that's caching in a nutshell. The plugin will automatically take care of installing and configuring Workbox to cache files from the network. It'll be able to intercept requests to load the application faster. We'll continue in the next lecture. In this lecture, we're going to learn how to add data persistence with Firebase. At the moment, the application is working offline, but it's not perfect. I've turned my internet connection off for this demonstration. If I were to scroll down, I wouldn't be able to view music uploaded to the application. Workbox does not cache data requested from APIs. It's been configured to cache static files like images, CSS, and scripts. It is entirely possible to cache data from Firebase. We won't be using Workbox to accomplish this. The Firebase SDK comes with a solution for caching data. The best thing about using the Firebase SDK is that it'll prioritize network requests over the cache. This strategy is the opposite of the caching strategy Workbox uses. Workbox will deliver the files via the cache before using the network. We want to prioritize the network because the data may have changed. We want users to be able to view the latest changes. The SDK will only use the cache if the user is offline. This behavior is what we want. By default, Firebase will not cache data. We need to turn this feature on. We'll open the Firebase configuration file in our project. Firebase calls this feature data persistence. We'll want to turn this feature on after we've connected with Firebase. After we've defined the DB object in the file, we'll use it to call the enable persistence function. The enable persistence function will tell Firebase to keep a copy of the database on the user's browser. If the user disconnects from the internet, the SDK will switch to using the local copy on the user's machine. With this one line of code, we've enabled this feature. Firebase will take care of everything else. We don't need to update our queries because Firebase handles this process internally. Our code won't break. The value returned by this function is a promise. We don't need to handle the promise, but we should check if an error occurs. We'll chain the catch function after the function. We'll be passed in an argument called error. Usually, Firebase will throw an error if it's unable to keep track of data on the user's browser. This error will mean offline support won't work. In the callback function, we'll log the following message: Firebase persistence error, error.code. The error code property will help you identify why Firebase can't persist the data. In the resource section of this lecture, I provide a link to the enable persistence function. You'll find a list of codes for why the function failed. Feel free to implement a different solution for handling errors. We'll keep it simple by logging a message. Just like that, we have enabled data persistence in Firebase. There are some things you should be aware of when using this feature. The first thing to be aware of is that the user cannot log in if they haven't already done so. Authentication requires a server. However, if the user was logged in before they went offline, Firebase will let the user be authenticated into the app since a token is stored locally. If the user is not logged in when they're offline, they won't be able to log in. The second thing to understand is that storage is limited. A copy of the database can take up room on the user's machine. Most mobile devices are limited with storage. Firebase will do its best with managing data, but we should be mindful of how much data we are requesting. Lastly, uploading files is not supported. If there isn't a connection, a file can't be uploaded. There's no getting around that. We'll need to handle this situation in our application. The uploader we created in our application will not be able to handle offline uploads. We'll need to update it to output an error if the user is online. Let's handle this problem before we test the application. We'll fix this problem in the next lecture. In this lecture, we're going to handle uploads while the user is offline. Firebase does not support uploads if the user is offline. We'll need to make sure we throw an error at the user if they attempt to upload a file while they're offline. We're going to be working in the upload component file. We have a method in the component called upload. This function is where we handle the upload for the files dropped on the upload. This includes the fallback solution we added if the user can't drag and drop files. Inside the function, we're looping through the files with the forEach array method. Here's how we'll handle uploads if the user is offline. Inside the loop, we'll check if the user is online the moment they initiate the upload. The first conditional statement we have in the loop will check if the MIME type is an MP3 file. We'll add another conditional statement after this one. The condition will check if the navigator.online property is equal to false. The letter L in the word online is capitalized. The online property will be a Boolean value we check if the user is online. If they're online, we'll let them proceed with uploading a file. If they're offline, we'll output an error to let them know they can't upload files. In the conditional block, we'll return the function. Before we return the function, we'll add an item to the uploads array. It'll be similar to when we upload a file, except the upload progress will be turned to red to indicate an error occurred. We'll call the push function on the this.uploads array. We'll add the following properties to the object we're pushing into the array. First, we'll set the task property to an empty object. The task object is used to get information about the download. However, we're not going to initiate a download. We won't need it. We'll leave it at an empty object. The next property we'll add will be called current progress. Its value will be 100. The current progress property is used to set the width of the progress bar. We're going to set it to 100 to tell the user an attempt was made but failed. Afterward, we'll add a property called name. Its value will be the file.name property. This property will represent the name of the file. Up next, we'll add a property called variant. Its value will be set to bgred400. This property will change the color of the progress bar. The next property we'll add will be called icon. Its value will be FAS/FA times. Then, we'll add a property called text class for changing the color of the text. Its value will be set to textred400. We're finished. It's time to give our application a test. In the command line, turn the server off. Next, run the npm run build command. Let's preview the application by running the npm run preview command. Open the site in the browser. We're going to start with a fresh slate. I recommend opening the application panel in the developer tools. In the Clear Storage menu, clear the storage from the browser. This clearance will log us out of the application. We will need to refresh the page if we want to cache the files again. We'll have a fresh copy of the files in our browser. I'm going to quickly log in. We want to test two things. First, we want to test if we can browse the application offline. Secondly, we want to test the uploader. It should reject the upload if the user is offline. We're going to visit the Home and Manage pages. We want these pages to be in the cache. Otherwise, the app may not be able to work offline. I'm also going to view some songs. After caching the pages, let's test if it works offline. We'll select the offline option to cut internet connectivity. After doing so, let's refresh the home page. If we look at the bottom of the page, we'll find the list of songs are rendering. Firebase will attempt to query the database for the songs over the network. It'll notice we're not connected to the internet. It'll resort to querying its copy of the database in the user's browser. Firebase will take care of syncing the database in the user's browser with its database. If the user comes back online, it'll sync the data again. We're able to get this behavior with one line of code. Let's try testing if the upload functions. We'll navigate to the Manage page. On this page, I'll attempt to upload a file. The application will immediately throw an error. This error will give us a hint that there's something wrong with our connection. Great! We've successfully added data persistence to our application.